Today we are resuming lesson 5, finding the intercepts of a linear function. In the previous lesson, we looked at determining the x and y intercepts of a linear function using your graphing calculator. So let's look at the previous lesson. We looked at our goal was to determine the x and y intercepts of a linear function. And we discovered that the x intercepts are the point on the axis where the line crosses. So the x-axis, it's the point on the x-axis where the line intercepts or the line crosses that point. And the y-intercept is where the line or the function intercepts the y-axis. And at the point of the y-axis, the coordinate, the x is always 0. And in this case, it is 0, 4, because the line crosses the y-axis at the point 4. And the x-intercept the line crosses here where the x-coordinate at -8. So the intercept will be -8, 0. So that's x and y intercept. We also looked at the slope as a review. The slope is a negative slope because as x increases, y decreases. And the first one is a positive slope. We also looked at how we find the intercept using our graphing calculator. So we use a graphing calculator or Desmos on your either phone or computer. So for today's lesson, we are extending it. We're going to find the x and y intercept of a linear function using the technology and algebraically. The next lesson, we'll be looking at how to solve problems involving x and y intercepts of a linear function and to recognize limitations. So today's lesson, we are resuming from the previous lesson, finding the x and y intercept of a linear function. But we are going to not only use technology, but solving it algebraically. The questions are taken from your booklet, and these questions are from assignment 5. So we'll be covering questions 1, that there are 6 parts to it, and question 2. The next lesson we will be looking at questions 3, 4, and 5. So you'll need your graphing calculator if that's what you're using to find as a technology. So or if you're using Desmos, you can use it. Also, what you would like to have handy with you if you're using the graphing calculator, so if this is your main usage, you'll want to have this sheet handy with you to find the x-intercepts, 2 sides. Or if you're using Desmos, we can have this with us here. So these are the things you'll need. Let's see, a pencil or pen. This question here asks to sketch a graph of each of the following functions, clearly label all intercepts. Okay, you'll be sketching it. And you're asked to find the x and the y intercepts. Now, I'm going to use graph paper, but you don't have to because it's. And the first one is y is equal to 3.41x plus 1.22. Now, we'll use our graphing calculator to demonstrate that. So in your graphing calculator, I'm going to turn this off. Now, you may want to reset your calculator for those of you who prefer to reset it. Now, if the screen comes up, you see there, do not show this message again. You can just press enter and continue back to your blank screen. Okay, so to reset your calculator, and the instructions are on your sheet here. Question, instruction 1. Second, the plus sign here, and go to number 7. Enter, press enter again, and go to number 2, reset. So that would clear your calculator of any information you had before. So now we're working with a clean calculator with no data from our previous work. Now we're going to enter your equation, which is 3.41x plus 1.22. Now you have your equation, and you press the graph button, and the equation or the function will appear. If you have this version of the calculator, you'll see it in colors. Now, it's very difficult to see where it intercepts the x and y axis here. So you may want to zoom in. Once you more or less zoom out, you can't see very much. One of the things you want to do, you can do it one of two ways. One, you can go to the window and adjust the window settings. The other one, a shortcut is to zoom. And to zoom in, you could either press the zoom in button, but the easiest one is to press number 4 decimal. So you can go to this. So again, this is your graph. Press the zoom button, and you can go to number 4. And that will automatically zoom in, so you can see better there. Now, the alternative is to go to the window. Now, right now, it's going from negative 6.6 to positive 6.6. So this point here is negative 6.6 on the x-axis. This point here is positive 6.6. To the y, negative 6.1, 2, 3, 4, just over 4 point something, and going up 4 point, maybe 2. Let's see what it is here, 4.1. So that's your domain and range on your window here. If I wanted to adjust my window screen, I can always go back to window and change this to maybe negative 4 to positive 4. And notice you will see more details of your graph. So right now it looks like it's just above 1 as your y-intercept, and the x-intercept is between negative 1 and 0. So we don't know exactly what it is by looking at it. So we'll have to perform the process of finding the x and y-intercept. Now, all of this is in your booklet on page 25 in the booklet. So if you need to look at what the screen would look like, you may want to go to the booklet on page 23 and follow this. Here is your equation, and now define your y-intercept. And the next page will give you the instruction to find the x-intercept. Okay, so I'll walk you through this here. So I'm going to do a sketch here on my graph. So now here I have my equation. I'll zoom in a little bit here so you can see some detail. Okay, So I'll label this as my 1, 2, 3, 4, -1, -2, -3, going up 1, 2, 3, and -1. So this is my x-axis, this is my y-axis. Now from my, clear that. I notice it is just above 1 and between 0 and 1 here. So I'll need a ruler to connect the 2 points. So it's approximately here. So I'll do a sketch. Remember, it's a sketch. It's not as precise as you would get in a calculator. So this is the equation, or the function. So that's your sketch. Now they ask you to label all intercepts. So this is the first intercept here, and this one here. We need to put the value where it crosses the y-axis in this case here, and the x-axis. Now here on your graphing calculator, zoom out. First, let's find the y-intercept. To find the y-intercept, you press the second button, and trace. Okay. And that's found on step here. Second trace through value 1 and put it, in this case, you'll put let x be 0. Because at this point here, we know x will be 0, but we don't know what y is. And that's what we're going to find. Now, but again, you go to second, go to my graph, second trace, enter, let x be 0, and press enter again, and it's 1.22. So this is 1.22. So this point here is 1.22. Now we need to find our x-intercept. At this point here, y is 0. I'll just put that as my x-intercept. Sorry, y-intercept. Now I'll need to find my x-intercept. The second trace. Now, there are 2 ways of doing this. In your booklet, it gives you the intersecting point. So let's look at your instructions here. It said enter here your equation, y1. Now it asks you to put in the y2 as y equals 0. So I go back to my y equal button. So here's my equation, which is, I'm just going to show you here. Instructions. So here we have enter the equation, which is already entered. Next, in line 2, we let y be 0. That gives us 2 equations, y equals 0 and y equals 3.41x plus 1.22. Now, press graph, you will see both of those equations. This is your y is equal to 3.41, 1.22, and this is y is equal to 0. By doing this now, I have 2 lines, and one of the line is exactly on the x-axis. This process allows me now to find where the graph y equals 3.41 plus 1.22, which is a blue line in blue, where it intersects the red line, which is y equals 0. The intersecting points here will give us the x-intercept. That's the reason for letting y be equal to 0, so we can find the intercept. The intersecting point. The intersecting point now gives us the x-intercept. The next step, we press second trace, and you want to go to number 5, intersect, not the value. The value we find the y-intercept. We go to now toggle down to number 5, press enter. Now it says first curve. Now, when it says press the left arrow key and go down to below here, the x-axis. So this is the left arrow key in the top here. So press this down, go down, and then you press enter, enter again, and enter one more time. And that will give you the x-intercept. So y is 0, and the value for x in this case, it is negative 0.36. So negative 0.36. That's your x-intercept. So put that. Now, for you, you'll probably want to do a sketch on your graph by. Remember, it's a sketch. You don't have to be as precise. So we have 1, 2, negative 1, negative 2, 1, 2. So here's our sketch. And you know that point there is 1.22. And this point here is negative 0.36. Now, if you were to use Desmos, you enter the equation in Desmos, which is 3.41 x plus 1.22. That's all you have to do. And then you go, then you zoom in. Now you can hit that to get you zoom in here. To find your x-intercept, you tap on where the x and y axis meet twice. And there is given you as negative 0.357. We run it up to negative 0.36. And positive, you could tap, and the y-intercept is 1.22. So it's much more straightforward with Desmos. You don't have to toggle right or left forever. Let's look at the next one. If you do well, I won't use the graph paper again. I'll just use a sketch here. One. Now, by the way, remember, if you were to look at the end behavior, right? So end behavior refers to what quadrant? Remember, this is quadrant 1, quadrant 2, and quadrant 3, quadrant 4. So the end behavior the end behavior we are referring to what quadrant the quadrant this graph is coming from or is going to. Now, because it is increasing, it's a positive slope because there's a positive sign in front of the 3.41x. This graph now ends behaviors from quadrant 3 to quadrant 1. So we can see it's quadrant 3 to quadrant 1. Notice it's not quadrant 1 to 3. In this case, it's quadrant 3 to 1 because it is increasing. So you're looking at, as your x increases, where is this graph heading towards? So if it's heading towards quadrant 1, we say it's increasing. On the other hand, if it was heading towards quadrant 4, it's decreasing. So we say in quadrant 1 to quadrant 4. So the x coordinate determines the direction of the end behavior. So if your y value is decreasing, then it's going to quadrant 4. If the y value is increasing, as x increases, you go to quadrant 1. The next one, let's try Desmos first on this one here. See, so I need to go back to my cell, so I'm going to remove this one here. Zoom in a little bit. Now I'm going to enter my equation, y is equal to 4.33 x minus 5. Now I want to see more of my graph. Notice it's the y-intercept. And remember, we talked about the general equation of a straight line is y equals mx plus b. So this is your b, so it's negative 5, which is a y-intercept. Check it again. So this goes down to negative 5. So this guy gives you 1 point, so it's slightly greater than 1.15, so it's slightly above here. So these are my intercepts. So your intercept, now I'll take my ruler, construct a straight line. So end behavior is from quadrant 3 to quadrant 1. So my intercepts, so my x-intercept equals 1.15, and the y-intercept y-intercept is equal to negative 5. And it's going from quadrant 3 to quadrant 1. If you use a graphing calculator, I'll go clear. Notice if you use a graphing calculator and you're finding the x and the y-intercept, do not change your y2 equals 0 because you'll be using it repeatedly. What you will be changing the equations given to you, or the function. So I'll clear this one. So I enter my 4.33x minus 5. So I know my y-intercept is minus 5, press graph, and it's way below here. So I need to zoom out. So I can actually go in here and put standard. Now standard, when I go into the menu, when I press my zoom button, I get a menu. Standard means you're going from minus 10 to plus 10, minus 10y plus 10. So, and that will be more or less zooming out. Now, why didn't it change? Let's go to standard. Oops. Oh, there we go. So now we can see our y-intercept is -5, and the x-intercept is around, well, we know it's between 1 and 2. So we'll find that. We'll find both. So let's look at the y-intercept. Y trace x equals 0, -5, which is what we have here. And we should have 1.15 or 1.155 for my x-intercept. Let's go down a second trace. I'll go down to intersect. And I'm going to go up here. Now I press enter 3 times. And 1.15, which is exactly what we have. Now the next one is quite an interesting question because it doesn't look like a standard one. But remember, we can change its form. We know negative, there's a -1 at the front here. So y is equal to -1x now. Now a negative times a negative is a positive. So this is our equation. Change its form. But you didn't have to change in this form. You can leave it as it is and enter it exactly into your calculator. So let's ignore this for a moment. We know the y-intercept now is 5.12, not negative, because a negative times a negative is a positive. So let's go to our y equal button. Zoom out a little bit here. Clear. Remember I told you do not remove the y2 equals 0 because it will be used repeatedly whenever you're finding the x-intercept. So enter the equation exactly as you have here. Negative, remember your negative sign? I'll just zoom out here a little bit so you can see a bit better there. So you want a negative in front, so it would be negative in the bracket if you're using the graphing calculator. Then I put the open bracket, x button here, subtract 5.12, close bracket, new graph. Notice now this graph is moving from quadrant 2 to quadrant 4. So we say it's a decreasing graph. The slope is negative, as we can tell from here. So let's do a sketch of this graph. Oops. Now notice the graph goes way above here. So I'll double this, 2, 1. Change my scale here. So I need more. This is approximately, you can tell from it, it's between 5 and 6. So we know this graph is going to the point the x-intercept. We don't know precisely the y-intercept, but we know it is somewhere between 4 and 5. So we'll find that using our graphing calculus. Let's find the y-intercept first. Second trace. Enter x equals 0, y equal to 5.12. So we know 5.12 up here. So y-intercept .12. Next, find our x-intercept. So we know it's from here, and somewhere between, say, 1, 2, 3, 4, 5. Seems to be close to 5, if not 5. So we know it's somewhere around here. We don't know what it is. Let's find that now. Second, trace, and then go to intersect. Number 5, press enter. First curve, I'm going to go close to my x-axis. Press enter, enter, enter again, and that gives me 5.12. Oh, look at that. Very unique. And you know why? Because the slope is equal to -1. So x-intercept is equal to positive 5.12. And this is going from quadrant. Let's get a ruler here. It's going from quadrant 2 to quadrant 4. Now, we haven't used the algebraic method yet, but the next 3 questions, I'll show you to do it algebraically and using technology. So here's the next graph. Y is equal to minus 4x plus a half. So we can tell right away the y-intercept is a half. So I'll do a sketch here. So, 1, 2, 3, 4. 1, 2, 3, 4. Oops, a little too space here. So let's go to our graph, and we'll go y. Now we change that to -4x. Plus, now you can change it to 0.5, or if you're not happy with using decimal, you need to put your fraction into a bracket. So open bracket, 1 divided by 2. That's how you enter fraction. Put a bracket and the numerator first, and then the division sign, then the denominator, close bracket. And that will give us our graph. Okay, notice I haven't changed my window. The window is still -10 to +10, -10 to +10, which is also the same as the standard here when you zoom. I can still see the graph. Now I need to zoom in. I need to get closer to see more detail. So I can go to zoom and press decimal number 4, and that will zoom a bit closer. So from here, you can estimate that the y-intercept is between 0 and 1, and the x-intercept is between 0 and 1. Now, we know it's a half from our equation, but we'll confirm that. So we go second, trace, you're finding your y-intercept, x equals 0, y equal to 0.5. So we know that right away. It's my 0.5 here. So I can write here y-intercept, y-intercept equals 0.5. Now we need to find the x-intercept. to find the x-intercept, second trace, go to intersect, and you go down to close the x-axis, press enter, enter. Notice what I did there. Second trace, number 5. Now, this was up there a little bit. Now, I need to go down or closer to the x intersecting point. So I press my right arrow key and I move down. Then I press enter. 1, 2, 3. So the x-intercept is 0.125. So it's right here. So the x-intercept is 0.125. So now I can construct my line. So this function is going from quadrant 2 to quadrant 4. Its negative slope is decreasing. So that's why I know, because this is negative here, is decreasing. Slope is going down. Now, with Desmos, it's more straightforward. Okay, I'm gonna back here, get rid of that equation. I can enter y equals negative 4x plus. Now the good thing about Desmos, it would automatically enter the fraction for you once you put 1 divided by. So it's 1 divided by. It automatically changes to a fractional form, as we know it here, divided by 2. And that's all you need to do. And you toggle down here, and this your zoom in. You tap it twice. And here are your intercepts, 0.5 and 0.125 for your. Now, as I mentioned, how do you go about finding the x and y intercepts algebraically? Now, these are a little bit, so using algebra now, all right? So this is decreasing. So algebra. Now, step 1, to find the x-intercept, for y is equal to negative 4x plus, I'll put 0.5 here. So we want to find the x-intercept. I'll just highlight that. Remember where the x-intercept is located, the y is 0. Remember, for example, here, this point here is 0.125. So this point here, we can write it as, sorry, so the y is 0, so it would be 0.125. So this point is 0.125 is your x value, and your y value is 0. So you want to let y be 0 and solve for x. So this is our equation. So we're going to let y be 0. So if y be 0, so 0 is equal to negative 4x plus 0.5. Well, now we're going to solve for x. Now, this is negative 4x, so I want to move this negative 4x. You want to isolate the x's. But since it's negative, I want to make it positive by moving on the left side. And the reason you can do that is because you can be subtracting on the right side. So let's look at this here. So 0 is equal to negative 4x plus 0.5. I want to move this away from the intercept, the y-intercept. So I'm going to subtract 4x over here, and this negative 4x over here, plus 0. Negative 4x, plus, so negative. So I'm adding. If I was subtracting, I'll have negative 8. So I need to add. By adding, I'm making this 0. So negative 4x plus 4x equals 0. So 0 plus 0.5. On the left side now is positive 4x. Because whatever you do on one side, which is just adding 4x, and we'll do exactly that on the other side. So remember, this is your equation you're solving. You must do exactly what you do on one side and the other side. Now we have 4x is equal to 0.5. So I'll rewrite it here. 4x is equal to. Now I'll solve for x. Now, because you're multiplying by 4x here, I want to get rid of the 4 by dividing. Well, if I divide by 4, I'll make the left side here 1. But I also have to divide on the right side of the equation by what I did on the left side, dividing it by 4. So let's do that here. 4x. So if I divide by 4, so I'm doing that on both sides. So remember, you have to, whatever you do on one side of the equation, you must do it on the other side, because you need the balance. You have to keep the balance going. If you don't, then it will be imbalanced. It wouldn't be equal anymore. So 4 divided by 4 is 1. So we have x is equal to 0.5 divided by 4, which will give us, and we'll calculate it here. Now, according to our calculation, the answer should be 0.125. Let's see what we'll have here. So I can, now to go, if you have your graphing calculator with you and you want to clear the screen, press the second button and mode, and you're more or less quitting what you're doing. Because the blue button indicates the function in the blue here. So if you press second and the delete button, you're actually going to insert. Or second and start button, you actually go into the list. So if I want to quit my original work, second and mode. Now I need to do my calculation. Here's 0.5 divided by 4, oops, not 4, by 4, which is 0.125, or 0.125. So x intercept, and that's exactly what we got here. Now, the same process you'll follow through. So to find the y-intercept, now, because in the y-intercept, over here, which is 0.5, in this case, the x is 0, so we have 0 and 0.5. So x is 0, y is 0.5. So in the case here, we let y be 0. In this case, we let x be 0. So we have y is equal to negative 4x plus 0.5. Let x equals 0 and solve for y. So now if we go back to our equation here, if x here be 0, so let's bring it down here, y is equal to negative 4, x is 0. 0.5. So this will give us 0. So y is equal to 0.5 or 0.5. And that's what we ended up here. let's find the x and y intercept using the algebra method. Okay, so we'll do one more question using algebra. And now we have y is equal to -7/2. Now -7/2, you can write it as a decimal by -7 divided by 2. So which is equal to y is equal to -3.5. Now this would be a line here. Oops. Oh, too extensive here. So -1, 2, 3. So here -4, 1, 1, -1, which is across here. So y is equal to -3.5. So your y-intercept is -3.5. That's pretty straightforward in the sense that there's no x-intercept, right? So no x-intercept. And the y-intercept is equal to -3.5. Now, there's no need for any algebra here because it's pretty straightforward. The slope is 0, and there's no x-intercept. The last one looked like a little tricky one, but the slope here is negative. It might have switching the y-intercept to the front instead of the back. So this could be rewritten as 9.5x plus 2. So your y-intercept, that's your slope, negative slope. Let's put a little sketch here. So let's use Desmos first to sketch the graph using technology first, and then we'll do it use algebraic method. The first thing I do, I enter. Now I will go ahead and enter my equation. The equation is given to me, which is this one here. Doesn't matter. I just did this part to show you that the y-intercept should be 2 when we construct our. In other words, the line should go through the point 2 here. So let's see if that's true. That's exactly. So we have y equals 2 minus 9.5 x. Okay, let's go on to our graph. Let's zoom in. Now, what are our y-intercept? Our y-intercept should give us 2. Let's tap on it. Exactly, it's 2. So now we know this line to this point here. And what's our x-intercept? 0.21, somewhere less than a half. So these are my intercepts. So I construct a line. So this is my, so y-intercept equals 2, and x-intercept equals, using my 0.21. Now, I'll just draw a line here because we'll find the x and y-intercept algebraically. Then it's moving from quadrant 2 to quadrant 4. So this is my x and y intercept equal to 2 to quadrant 4. Now, for your graphing calculator, fans of graphing calculator, we'll do that for y equal button. Clear button. Then we have 2. Now, in this case here, you don't need to use a negative. You have to use a subtract. Don't use a negative. The only time you use a negative is when the slope is the first term and is on the right side of the equation. So in this case, I'll rewrite exactly here. Then I use a subtract sign, 9.5x, and I graph. Notice it's really could see it here. So, but what I'll do, I'll zoom. I change the window by reducing my domain or the x values here. So I go to my window. Instead of making it a -6, I'll probably make it -2 and positive maybe 2 here. And that I'll be zooming in even closer, and you can see it a bit much better because 1 is here, and we know it's less than a half the x-intercept, which is what you have here. Let's find the y-intercept first. Second trace value, press equal 0. So it's 2. So we know that's 2 there. Let's find our x-intercept. We already have in y2 equals 0. So second trace, and you go to intersect, and you move closer to the y-intercept. I press enter 3 times. And that gives 0.21, which is exactly here. So our y-intercept 2, x-intercept is 0.21. That's the technology. But if you don't have the technology, like a graphing technology, let's find the x and y-intercept. So to find the x-intercept, as we know, let y equal 0 and solve for x. So we have y is equal to 2 minus 9.5x. If y equals 0, so we have 0 is equal to 2 minus 9.5x. Now, I want to isolate the x, so I will subtract, I'll add 9.5x on both sides. So we have equals 2 minus 9.5x plus 9.5x. So I'll put that here. Now the 0 doesn't have any value in this case. We can put 0 in here. So be sure that we're acknowledging the 0 is there. So negative 9.5 plus 9.5x give you 0. So I have 2 on this right side. So on the left side, I have 9.5x. Now I need to divide both sides by 9.5. So I can have 1x here by dividing 9.5. 9.5. So 9.5 divided by 9.5 is 1. So now I have x is equal to 2 divided by 9.5. This is where I need my calculator. And I'll quit that. So we have 2 divided by 9.5. That up a little way. So we'll put this part here again. 2 divided by 9.5, and the answer is 0.21, which is exactly what we have here. So x-intercept is 0.21 because y is 0. And to find the y-intercept, we let x be 0. and solve for y. So we have y is equal to 2 minus 9.5x. X equal 0. So here we have y equal 2. Here's my equation. If x equals 0, y is equal to 2 minus 9.5 times 0. So we have y is equal to 2. So this becomes 0. We'll write that down. So y is equal to 2. So the y-intercept is 2, and the x-intercept is 0.21, which is what we have graphically. So in your assignment, final assignment for this booklet, there are some questions required for you to find the x and y-intercept. You do not have to use the algebraic way. You can use your graphing calculator. It's applied math, so you're allowed to use it. If you're in pre-calculus, you'll be required to use the algebraic way. For applied math, you can use a graphing calculator, or you can use decimals. Either one works. So that's your x and y intercepts. And once you have that, you can find the quadrants it's going to. Now, by the way, I forgot to mention, this one is going from quadrant 3 to quadrant 4 as the end behavior. So quadrant 3, oops, not 3 here, this is 4. Quadrant 4. So those are questions for the first set of assignment questions. And you should make sure you at least try these questions on your own. And the reason for showing you is that you have a better understanding of how to do these questions either algebraically or graphically using the graphing calculator. Okay, the last set of questions we'll be working on is the final question, question 2. Page here. So question 2, let's make sure we get this oriented here. Now, if you haven't tried this yet, you may want to pause the video, try it out, and then look at your results. Okay, I didn't give you enough time to try, but let's find the solution to these questions here. So here's your equation. Y is equal to 6.28x plus 1.57. Now, the sign of a leading coefficient would be positive, right? Because here you have a positive sign in front of it. Okay. So in this case, you may want to use your graphing calculator. I'll go ahead and use the Desmos. Now, Desmos is, as I mentioned to you many times, it's less steps, but you can end up with the same result as the previous question. So we see the leading coefficient is positive. Put that down. Now the y-intercept, remember, it's 1.57. Because the way, remember the equation of y equal to mx plus b, this is your slope. Okay, so we do y-intercept. I'll show you this on their graphing calculator or your Desmos. So 1.57. Now, because it's positive slope, the end behavior is from quadrant 3 to quadrant 1. So it's quadrant 3 to quadrant 1. The slope direction, as you mentioned before, right? It will be positive, right? Its slope direction is increasing. Now the value of the x-intercept is very difficult to tell. Now the domain and range. Now there's no restriction. So this graph is going to the right forever and to the left forever. So the domain is all the real numbers and the range is all the real numbers. But let's look at it in your graphing calculator. And in this case, I'll use Desmos. So first thing I want to do is to enter my equation. Make sure I got this all right here. Oops. Okay, I'm going to change this equation here. Oops. It's acting up here. Now if you resume, y equals, I may have to zoom out so you can see. Sorry about that, I need to adjust my document. Y is equal to 6.28x plus 1.57. Now I need to find my x-intercept, so I'm going to zoom in here. Okay, so I can see both. X-intercept. It's negative 0.25. Notice this graph, if we were to zoom out, it goes to the right forever and to the left forever. So we can see the domain. See, x such as x is elementary numbers. There is no restriction. I'll show you later on when there's a restriction, how it's written. But in this case, all you can write is a negative infinity. And it has to be a smooth bracket there because you can't. This indicates you can't touch infinite, negative infinity. Neither you cannot touch infinity. Infinity is not a number; it's a concept. It means we do not know where it ends. Okay, we don't know that number, so we say it's infinity. The range will be the same thing. Now the range has to do the x values, how far it goes up and far it goes down. And this goes up to down forever. If I were to zoom down, I'm going down into the thousands here, and you can go to millions. The graph still goes down, still goes up, and also it still goes to the right. So we can say that y, such that y is an element of real numbers. That's your domain and range. So by now, you should be able to do the first part of assignment number 3 for Unit 3. So today, our main goal is to find the x and the y intercepts using graphing calculator. So let's go here and my code here. So our main goal today was to determine x and y intercept of linear function, and we do it using technology and algebraically. We did both the algebraic method and the graphical method using the graphing calculator or Desmos.